Hi, good afternoon, guys. All right, so it's still early, so we still got 15 more minutes. But if you have any questions about the class, definitely feel free to ask. But yeah, we'll start in 15 minutes.
Sounds good. Thanks.
Yeah. Let me go to the restroom real quick. All right, hey everybody. So we still got 10 more minutes. But so if you guys have any questions about the class, just go ahead and ask. So you can either turn on your mic or put it in the chat. So but we'll get started in 10 minutes. All right. Hey, everybody. So if you're just joining in, welcome. Welcome to the class. We still have about 5 more minutes before we begin today. So if you want to ask any questions about the class or just anything in general, just don't be shy. Okay. But we'll get started at 4 o'clock on the dot. Hey guys, so if you're just tuning in, we're going to get started in a couple minutes. So if you have any questions about the class or anything, just go ahead and feel free to ask. Hey everybody. Hey Josh.
How was your break, Dr. Tran?
It was good. It was eventful. It was exciting. I moved to a new place. I got engaged, so it was a lot of good things happened this break.
Wow, congrats.
Thank you. Thank you. Thanks, guys. All right, it's 4 o'clock, so let's go ahead and get started. All right, good afternoon, everybody. So this is our first class for EGME 410. So let me be the first to say welcome to the class, right? So this is, hopefully you guys have had some lectures up to this point, but if not, then welcome to the spring 2021 semester. So we're back at it again for another fun semester of virtual teaching. So, I'll be here in my apartment basically the whole time, and I'm sure you guys will be safe in your apartments too. But we're in this for another full semester. Okay. All right. So this class is Introduction to Finite Elements. So I know this is a class that's in high demand. So I'm happy to be here and happy that all of you guys are here with me. And so before I kind of launch into the our course introduction slides, are there any questions about the class or anything I can answer before we get started? Okay. All right. So yesterday I was having issues where when I was in slideshow mode, I couldn't see the chat. So we'll see how things go from here. But okay. So this is EGME 410. So this is finite element analysis. So I among all the classes I get to teach here at Fullerton, I think this is one of my favorites that I get to teach. Not only just because I've personally used finite elements a lot in my own work in the past, but for seeing what you guys work on in finite elements and just what you guys come up with for your projects is always really, really fun for me. So I'm really excited for this class and, really excited to see, what you guys can do, okay? Okay, so first, just a little bit about myself. So my name is Professor Justin Tran. So you can call me, whatever you want. I'm not picky with what you call me, right? So you can call me Professor, you can call me Dr. Tran, you call me Dr. Justin, Mr. Justin, just Justin, whatever's most comfortable for you. Because if it's comfortable for you, then it's comfortable for me. Okay. Um, and so normally on this slide, I would put the location of my office, but obviously, my office is my apartment for this semester, right? Because no one's on campus. And so if you want to reach me, probably the best way, besides Discord, which we'll get to later, will be my email address. So my email address is right here. It's also linked on the course website, which we'll go over later. But it's easy to remember. It's justran@fullerton.edu. So I always joke every semester that I think I stole this email address from some running club at Fullerton, but it's okay because it's for me it's really easy to remember. Okay? So I'm local, so I grew up in Cyprus. So if you don't know where that is, that's about 10 miles west of campus. So pretty much right where near Cerritos is. And I did all my education here in California. So I got my bachelor's from UCLA, my master's from UCSD, my PhDs from Stanford, and all of it was in mechanical engineering. And in terms of research interests, what I've worked on a lot in the past is engineering applications for cardiovascular applications. And so basically what, maybe usually for this class, I give a presentation at the end about what I've done. But basically I've used finite elements to simulate blood flow. And I've used that to, study cardiovascular disease or even, design medical devices too. And of course, just because I'm an instructor in, an engineering department, I'm just naturally interested in, better ways that we can do this. Okay. So let's go over the learning objectives. So if you've had me before, you should be, very familiar with these. But if not, at the beginning of every class, what I like to do is I like to display what I call the learning objectives for the day. Okay. So you can kind of think of these as almost like an outline for, what we want to cover in the class for that day. But they go a little bit beyond that. So if you kind of read each of these learning objectives here, and you kind of read them, throughout the semester, you'll notice that they always start with a verb. Okay, and that's by design. And the reason for that is, what I want the learning objectives to be is a description of, what you should be able to do at the end of a lecture, at the end of a week, at the end of a unit. Okay. And so let's take this first learning objective as an example. Okay, so the first learning objective here says describe the use and utility of finite elements in engineering work. Okay, and so by the end of today, what you should be able to do is describe the use and utility of finite element analysis in engineering work. Okay, and so I start these with the verb on purpose so that just to show that what you should be able to do. And it's a great way to kind of check your own knowledge. Too, because if you go back and look at the learning objectives and you read, the statements, and if you can't perform this action right here, then that's kind of an indication that, maybe I should go back, maybe watch the lecture again, go through the lecture notes so that I can actually achieve these. Okay. And if you've known me by now too, then I really like to use these learning objectives as, good questions on the homeworks and exams too. So they're definitely very good things to check out. Okay. But we'll start every day with the learning objectives, and then because that'll basically guide our learning. Okay, so let's start let's start talking about, what this class specifically is about, right? And so, you're in this class for finite element analysis. So you've probably heard the acronym FEA before, okay? And so let's start by describing what it even is and, and why do we even care about it, okay? And so kind of for this, I like to start with just a textbook definition for finite element analysis, where it's basically a numerical technique for solving differential equations on arbitrary geometry. So there's kind of a lot of stuff going on in that one sentence. So let's kind of break it down, okay? And so let's start with this first part right here for numerical technique. And so I've underlined numerical there to kind of emphasize that finite element analysis, 90% of the time for practical problems is done on a computer, right? Of course, there's a lot of calculations that you can set up by hand, but a lot of the heavy lifting is done by the computers. Because just the way that finite elements are, it's designed is that it's designed to produce a lot of arithmetic, expressions that a normal human being just wouldn't be able to do, in a practical amount of time. Okay. All right, so the second part of this is, for solving differential equations, okay? And so what this part means is that, we can use FEA to solve any differential equation. So I think, a lot of people are probably familiar with how they use, maybe like a commercial software like ANSYS to do things like stress analysis or to simulate, beam bending and things like that. But what ANSYS really doesn't tell you is that underneath, all of those analyses are actually differential equations. And what ANSYS is doing under the hood is solving those equations and then just presenting you the results in kind of a visually appealing way. Okay. And then the last part of this is arbitrary geometries. And so this is a really key point right here, because this is what makes FEA really, really powerful, in that we can take basically any geometry that we can conceivably create in CAD, like in SolidWorks or something, and then we can perform a simulation on that. So that's really powerful, because a lot of times we can create really complex geometries in CAD that we'd have no hope of trying to solve with by hands, without a computer. Okay. And so just to kind of expand on this, finite elements, we're going to leverage computers to perform, all these calculations that just humans just do not have the capabilities to do. Okay. And so what does this allow us to do? And so since, all of this is in the computer and it's so fast, this allows us to really design and analyze engineering systems that are just kind of way too complex to perform with hand calculations. Okay. And let's be real here. Most engineering systems that people will actually pay you to analyze, those are probably going to be too complicated for you to do, with just hand calculations. So, most practical engineering systems, you're going to have to rely on finite elements or some kind of computer software in order to analyze. Okay. Okay. And so with that, let's talk about some different kinds of analysis to kind of drive that point home. Okay. But before I do that, are there any questions? Of course, I can't see the chat. Okay. Any questions so far? Okay. Oh, question? It's working today. Okay. All right. Okay, so let's go over the types of analysis. So this kind of builds off just the previous slide, right? And so, when we say that we want to like tackle an engineering problem, or we want to analyze it and we want to perform some calculations, there are kind of what I consider three main approaches to actually doing so. Okay. And so the first category of approaches is known as analytical. Okay. And so these are probably the techniques that you're probably most accustomed to if, in all the rest of your classes. Okay. And so these refer to what I call like pen and paper calculations. So these are problems where we can solve the governing equations. We can solve like Navier-Stokes. We can solve like, the heat equation, and we can solve it by hand. But in order to do so, we have to do it on very simplified geometries and very simplified conditions. Okay. And so in cases where, the geometry and conditions are simple enough to do so, this is really fast and it's really inexpensive, right? You just have to pay an engineering student, or you don't even have to pay them, just give them a pencil and paper and, and they'll solve it for you, okay? But of course, this is extremely limiting. So you can only do this for the simplest of problems, which most of the time are not the most interesting, okay? Okay, so the second approach that we can take is known as experimental, okay? And so experimental, what I mean by that is just go out and run an experiment and just try it, right? And so if you're curious to see, if your car can survive hitting a brick wall, just go and run your car into a brick wall. Take all the safety precautions, of course, but then, that's the best way to kind of find out, if something's going to happen, is just try it out in the real world, okay? Because, there's nothing that can predict reality better than reality itself, right? Mother Nature is kind of the best computer in this situation, okay? And so the advantages of experimental is that any data that you get from an experiment or any kind of physical test is always going to be kind of the gold standard, because it actually happened, right? So there's no kind of arguing whether this will happen or not, because it actually did, right? And the nice thing is that with the experiments, if you set it up right, you can handle basically any kind of complex situation that you can think of, right? But the downside of this is that to set up an experiment and to destroy your car or something like that, obviously that's going to be very costly, right? No one wants to run their car into a brick wall just to see if it's going to survive, right? Because no one wants to pay for a new car for that. Okay. Not only that, but it's also very time consuming, because a lot of times you try to set up these experiments and it takes sometimes it could take weeks or months to do so in kind of, in a professional sense. Okay? And so the third approach that we have is known as computational. Okay? And so computational, finite elements kind of falls in this last category here. And so it's kind of similar to analytical in that we're relying on the governing equations. So, we're starting with like the Navier-Stokes equations or the heat equations, and we're going to solve those. But instead of doing those by hand, we're going to let the computer do kind of most of the hard work. Okay. And this kind of gets us, at least in my opinion, kind of the best of both worlds, right? And so you have this kind of, because you're not doing a physical test, it can be very fast and very inexpensive to do a computational analysis. But because, the computers are doing most of the hard work, you can handle very complex situations. So you kind of get the best of both worlds. But the downside to computational is that, it can be really tricky to set up properly, and it can lead actually to a lot of misleading results. And so what can happen a lot of times is, for people who aren't really trained in finite elements or trained in the software, they can run a simulation on ANSYS, but they might get a result that they might think is true, but they set it up all wrong, and it's actually kind of more dangerous. So the downside to computational is that it can kind of trick you into thinking that the results are good when it's not really. So you have to, in order to use computational, you really have to know what you're doing in order to set up the problem, properly. And that's what this class is going to be all about. Okay, so let's do some examples to say, comparing, what you would do, in a previous class versus what you can do with finite elements. Okay. So in a previous class, probably you've had a problem like this where, you were asked to solve for, the deflection in this beam, right? So you have a beam, you have a pin support on the left, you have a roller support on the right, you have some distributed loading, and you were asked to solve for, the deflection, okay? And so that's great. So, we have equations for this. We have the Euler-Bernoulli beam equations, and we can solve for it, right? But, I kind of hate to break it to you guys, but, no one's going to pay you professionally to solve a problem like this. So, you're probably going to, in order to actually get paid by an engineering company, you're probably going to need to solve problems like this, right? We have kind of a very complex structure here. So this looks like, either a parking garage or maybe like a rack to kind of store a lot of things, right? And you want to see, what are the maximum stresses that these, joints can hold, right? And so obviously, a problem like this is way too big and way too complex to solve by hand. But you can do this with finite elements because, again, the computer is going to do all the hard work for you, okay? Given that you set it up correctly. Okay, so let's do an example from heat transfer. So, probably from, if you've taken 407 before, or maybe you're taking it right now, you might have seen a situation like this, or you will, very soon. Excuse me. So where you have like a rectangular slab of material, you have a temperature on one end, a temperature on the other end, and you can solve the heat equation for the temperature distribution, okay? And so again, this is fine. It's cute, but again, no one's going to pay you to solve a problem like this. Okay, and so you're probably going to want to solve a situation that's more complicated like this, right? So here we have like a turbine that might be exposed to some really hot gas, and so you want to solve for like the heat the temperature distribution in this turbine as it's rotating, in order to kind of design it better, right? And again, something like this, there's no way you'd be able to do it by hand. And so you need to be able to, use computers to basically help you out with these computations. Okay? And then let's do one last example with fluid flow, right? And so let's say that we have fluid going into a pipe like this, right? So we have, pressure in, pressure out, and this is going to develop a velocity profile. And so, in a situation like this, we can simplify the Navier-Stokes equations such that we can, solve for the velocity profile, and that's great. That's fine. But again, this is kind of too simple to be used for anything practical. So, if you want to do something like this, where, this is a simulation that I didn't do this one personally, but it was a close colleague of mine where he was designing basically a new surgical procedure where he's basically putting an injector pump inside someone's, blood vessels in order to kind of help a failing heart, right? And so if you want to do something with like really complicated geometries and really complicated flow patterns, you need to kind of rely on computers in order to help you do this. Okay. Okay. And so at this point, I want to throw it to you guys. So I know that, a lot of you guys are coming in with, with problems that you want to examine with finite elements, with applications that you want to explore. So just go ahead and shout them out, put them in the chat. Let's, let's hear what you guys want to do finite elements for. steam wiper, but we can do that after. Yep. So comment in the chat. So senior project with non-Newtonian fluids. Yep, I've talked to you guys. So that's definitely, a really great example. So, anything where you have, really complicated physics like non-Newtonian fluids, and in your guys' case, you want to do like an impact problem too, where like you're simulating impact, definitely you would need finite elements to do that because that's hard to do by hand. Right? Okay, another comment in the chat. So ceramics kiln. Yep, definitely. That would be a really good one. So ceramics are really interesting materials. So, anytime you have kind of a very complicated material like ceramics are really brittle, and so in order to compute that, you really need something like finite elements to do that, right? Dynamic forces on a suspension system. Yeah, definitely. Suspension systems, very, very complicated structures. So definitely, simulations would help you a lot with that too. Okay. Frequency response and dynamics. Yeah, definitely. So maybe I think I'll work it into one of the activities. So right now it's not, but I know that there's a lot of interest to finding like resonant frequencies and things like that. So you can definitely do that in ANSYS too. So definitely, remind me later on and we'll go over that. Right. CubeSats, yeah, definitely. A lot of people in past classes have done simulations on CubeSats too, both structural and thermal. So definitely very, very interesting area too. Race car roll cage impact testing. Yeah, impact testing definitely is a really great finite element application. So we're going to, one of our activities, activity number 4, we're going to be simulating an impact test too. So you can definitely use that activity to help you out with that. Yeah, great examples, guys. Anyone have any other applications or problems they want to use finite elements for? Okay. I want to see if my senior project can survive vandalism. that might be a little bit hard, but we can see if we can we can simulate that too. Yeah. All right. So yeah, lots of great examples, guys. So this is this is why I love this class. Is you guys have so many interesting applications for finite elements. Can we do cyclical loading? Yes, you definitely can. And one of the activities we're going to do later on, we're going to do a fatigue test with cyclical loading too. So that's definitely on the docket for the class too. Mm-hmm. Okay, so let's go ahead and continue on. Okay, and so let's talk about what's the actual process that we need to undergo to perform a finite elements. We talked about, because up to this point we've talked about all the great things that finite elements can be used for. But how do we actually go about this process? Okay, and so what I'm going to show you is kind of, these are kind of the general steps that are typically done to perform finite elements. If you're using a commercial software, the software is going to handle a lot of this under the hood for you, but it's kind of important to understand, what the computer is actually doing, just so that you can debug issues later if some come up. Okay. And so the very first step, in any kind of finite element situation is to take your geometry and discretize it. Okay. And so you can see on the right here, I have an image of this, this fitting right here. Okay. And you can see there's a lot of lines that are drawn on it to kind of break it up into, these geometry, into simple geometries. Okay. So it almost kind of looks like it's pixelated in a way. Okay. And so the point of this is to, basically take a geometry that might be really complex, and then break it up into a lot of smaller shapes that are much, much simpler to do. Okay. And so it's a little bit hard to see here, but basically all these little boxes right here are exactly that. They're just little boxes. Okay. And so instead of one kind of big complex geometry, you instead have a lot of really tiny, simple geometries. Okay. And that's actually really, really key to doing finite elements. Okay. And so this process of breaking up your geometry into simple ones, this process is often called meshing. Okay, and that's the terminology that's often used within ANSYS too. So in ANSYS, when we do our first ANSYS activity next week, there will be a step where we take our geometry and we mesh it. And so when I say meshing, all I mean is to take the geometry and break it up into simple ones. Okay. And then the terminology used for each individual shape here is known as an element. Okay. And so that's where the element and finite element comes from. So an element refers to one of these, one of these shapes here. Okay. Okay. And so the next step in the finite element process is to assume a solution. Okay. And so, luckily, if you're using a commercial software, ANSYS kind of does this part for you because it kind of involves a lot of math. We're going to dive a little bit into it, for simple problems, but I want to mention this just now. Okay. And so this might seem like kind of a silly step here, right? Because, like I mentioned at the beginning, when you're doing finite elements, you want to solve for the solution to a differential equation. Okay. But in order to do that, we actually have to kind of assume, what our solution actually looks like first. Okay. And so, for the most cases, we assume that our solution either looks like a linear function or a quadratic function. Okay. And so the funny thing is that, a lot of times with these complicated equations, the solution is not just a linear function or a quadratic function, but we have to assume that it looks like that in order to actually get a solution. Okay. But what the hope is that, if you assume a solution, a simple solution, but then you basically mesh your geometry such that, all the elements are small enough, then you're going to get a solution that's close enough to reality. Okay. And we'll go through this throughout the class, but I kind of just wanted to introduce just kind of the concept to you. Okay. And so these functions here, the ones that you assume for the solution, these are called shape functions. Okay, so you'll hear that term used quite a bit throughout the class, especially in the latter half of the class. Okay, and so once you've assumed the solutions on all the different elements, the next step is to assemble. Okay, and so by assembly, what I mean is to basically take every element in your mesh, and each of those elements will have basically a set of equations that governs them. Okay. But in order to actually solve the entire system, we have to take all of those elemental contributions and then put them all together into one big linear system. Okay, so I call this the global system. Okay, and so the global system is nothing more than just a very, very large system of equations. Okay, and so you can see here, we have a 5 by 5 system. So this is a system of 5 equations and 5 unknowns. Okay. And so, when we do finite elements, this is kind of what it's doing underneath the hood. So ANSYS is doing this under the hood, but it's an important step. And the reason we do this is that, the funny thing with computers is that they're actually really bad at solving differential equations, but they're really, really good at linear algebra. Okay. And so if we can take, and so the goal with finite elements is that if we can take a really complicated system governed by differential equations and turn it into a linear algebra problem, then the computer can solve it kind of just like that. Okay. And so a lot of the theory that we're going to learn in finite elements is how do we take really complicated situations and then turn them into a system of linear equations? Because once we get it to that point, then the computer can kind of take it from there. Okay. Okay. And so the next step that you're going to have to do this part manually for your in ANSYS is to apply boundary conditions. Okay. And so what boundary conditions represent is the behavior of the solution at the boundaries of your geometry. Okay. And so a lot of times you'll see this when we do our first activity next week, is that we have to fix our geometry in place, right? So let's say that we have this crank right here, right? And so we would apply a boundary condition maybe on this side where all the little pins are, just to make sure that that part doesn't go flying off to infinity, right? And so that's what's called like a fixed boundary condition or fixed support. Okay. And so the other thing that we have to add into our simulations is the loading. Okay. And so this is kind of any kind of external force or external pressure that's going to be applied on our system. Okay. And so in this picture that I have right here, these red arrows here are representing a force that we're applying onto the crank. Okay. And so that could be the force of someone that's pushing this crank or that wants to turn this crank. Okay. And so that's going to be important too. Okay. And so whenever you run a finite element simulation, it's never complete, without applying your boundary conditions. Okay. So you need at least one, fixed support, and you need at least one load too. Okay. And then, throughout this class, we'll see, how this actually affects our linear system and how it affects our solution. Okay. Okay. And so the next step in the process is to just solve. And so, I say solve, but this is actually the computer's turn, right? And so this is the part that the computer actually does. So now that we've done all this work to set up the system, apply the boundary conditions, now it's the computer's turn to say, I got it from here. Okay. And so now we have basically this giant linear system, right? I showed a simple one here with 5 by 5, but it's not uncommon for a lot of these systems to get like 10,000 equations for 10,000 unknowns, or even like a million equations for a million unknowns. So at this point we have to rely on the computers to kind of do the work for us. But the good thing is computers are really good at this. And so once we reach this point, we kind of just let the computer do its thing, and we kind of just wait for it to get the solution. Okay. And then once the computer gets the solution, we can then look at them and kind of analyze our results. And so this is the step I often call post-processing. Okay, because after the solution is obtained, then we can do things like look at the stress inside this inside the system, look at the deformations, right? Look at the temperatures, look at the heat flux, right? And so this is where kind of the engineering happens. So this is where you would look at the results. You say maybe the stress is a little bit too high here, so let me kind of adjust the geometry and adjust this this part, such that we don't run into this issue. Okay. And so if you're using a commercial software like ANSYS, ANSYS will automatically produce these kind of beautiful heat maps or color contours for you. Okay. But if you are writing your own code, which we're not going to do in this class, but if you have interest to, then you have to this is kind of another step that you have to write as well. But the nice thing about using a commercial software is that it does most of this for you. You just kind of have to tell it, what results do you want to see. Okay. Okay. Any questions on this so far? Okay. Okay. All right. So another question that I always get asked. I have this slide, but people ask me anyway, right? And so why do we want to bother learning the concepts and the background knowledge, right? Because I know that a lot of you guys in this class, you guys have a lot of interest in learning how to use ANSYS, right? And that's great. ANSYS is a great software, and it's used by a lot of industry. Okay. But we're also going to spend a lot of time, learning about the theory and the concepts behind, finite elements. Okay. And it's going to be painful, right? I'm not gonna lie to you guys. Okay. But there's a good reason that we're doing this. Okay. And so the first reason is that finite element simulations, even though they can be extremely powerful, they can simulate really complicated things. It's not God. Okay. So I if there's one thing I want you to get from this class is that simulations aren't God. Okay. Just because you simulate it doesn't mean that it's truth. Okay. Because in reality, finite elements is just another tool that you can use to perform your engineering work. Okay. So it's really no better than like the hammer or a screwdriver, or any kind of tool that you use in your work. Okay. And the reason I say that is because just like any tool, it has its limitations, and it has its best practices, that need to be properly understood so that you can actually use it effectively, right? And just as a really quick example, right? So let's say that you have a nail and you want to put that into your wall, right? You wouldn't use a screwdriver for that. Technically you can, but it would be very difficult, right? So the tool that you need to use for that is a hammer, right? And so finite elements is exactly the same way. So it's just a tool. And so you need to, in order to actually use it properly, you need to understand, what its limitations are, how to set it up properly, how to best use it so that you get the best results possible. Okay. And so the second point I want to make is that even though, even when you set it up properly, and you understand it well, finite elements is not going to be, effective for every single problem. So it's not going to work all the time. Okay. And so, by understanding the fundamentals behind the technology, it will help you either debug some issues, or just simply say that, this is too difficult of a problem, or this problem is just not suited for finite elements. So, and that's really important for you to know as well. Okay. Because, when you guys leave this class, you guys are going to be considered experts in finite elements. Okay. And as an expert, there's a responsibility that you guys have to not only, understand your tool really well, but also just to be honest with it and to say that, there's some things that this tool can't use, and there's a proper way to use it in order to get the best results. Okay. And so that's why we're going to spend a lot of time with the background knowledge, because, all of that's going to be really important for you as an expert. Okay. Okay, so let me give you kind of another example of why this is important. So let's take a veterinarian, okay? And so your veterinarian, generally we expect them to know what I like to call procedural skills, okay? And so procedural skills will be things like, giving shots to animals, taking a blood sample, performing eye and ear checks. So I like to think of these as kind of like mechanical things that, that the vet has to do, okay? But nowadays you kind of see, a lot of vet techs or a lot of, nurses that are performing these things, okay? But for the vet, which you're paying a lot of money to take care of your pet, you also expect them to know what I like to call conceptual knowledge or the background knowledge. Okay, and so first of all, you would hope that they would understand why they're giving your animal shots, right? The worst feeling, or I would say not a very good feeling is when you go to the vet and your vet says, I want to give you all these shots and it's going to cost $400. And you ask them why, and then under their breath, they kind of say, we need to make some money, right? That's not a good answer, right? So you want them to be able to say, your pet is at risk for this disease because we saw these signs. And so we need to give them this shot in order to protect them, right? And so, we expect our vet to know that background knowledge or that conceptual knowledge in order to kind of understand why they're doing what they're doing, okay? So another thing is, if your animal's sick or it's not behaving well, we rely on the vet to tell us, what should we do to take care of it, right? And also just to interpret animal behavior, right? And so for a position like a vet, which we consider to be like an expert on animal health, not only do they need to know, how to manually do things, but they need to know kind of the background knowledge behind it too. And so for us, it's no different, except for us, our procedural skills would be like maybe using ANSYS or using finite elements. And we also need to know the conceptual knowledge of understanding, why we're doing certain things and, what goes into that. Okay. Okay. And so the next question that I get often too is why ANSYS? Okay. And so ANSYS, it's a great software, but it's only one software, right? And so it wouldn't be capitalism without, a lot of competing software. So there's other softwares out there. A big one that comes to mind is Abacus. Okay. And so why do we choose ANSYS for this class? So we choose ANSYS just because it's the most common. Okay. And so if you know ANSYS, then that's a really good marketable skill that you can put on your resume. Okay. But the good thing with finite elements is that once you know one software, it's a lot easier to kind of get into another software because the process of performing finite elements is the same, no matter what software that you're into, right? So whether it's Abacus, whether it's OpenFOAM, whether it's ANSYS, no matter what, you're going to measure geometry, you're going to apply boundary conditions, and you're going to solve, and you're going to interpret the results. Okay. And so I choose ANSYS because, it's the most common, and the interface is actually pretty nice. But the real reason that I like to use ANSYS is that there's a free student version that you can download. So anything that's free is always good. Okay. Okay. All right. So I think one last thing. Yes. All right. One last thing. We're going to cover this kind of later on in the semester, but one other really important skill that you're going to need to know as an expert in finite elements is to look at your results from your finite element simulations and then verify that and interpret it. Okay. And the reason for this, which we kind of mentioned before, is that finite element technology is not perfect. Okay. And so for some cases, it's going to give you a result that's completely wrong. Okay. It'll look nice. It might produce a really nice color contour, but it might be totally wrong. Okay. And so a really important skill to know when you're doing finite elements is that, when you get a result, when you get a simulation, is to perform some sanity checks that will help verify the solution. Okay. And so that's really important because you don't want to run a finite element simulation, not check the results, give it to your boss, and then, they're going to, and say your boss takes your results and they build a bridge and then the bridge just falls apart because, your finite element simulation was wrong. Okay. And so it's really important to always be kind of critical of your finite elements results. Okay. And then besides that, there might be some other what I call derived quantities that you might want from your simulation too. So one of the most commons is stress analysis. But if you're doing things like fluids or heats, you might be interested in volumetric flow rate and heat flux as well. Okay. Okay. And so that's kind of the introduction to the course. And so what I had planned next was to give you guys a tour of the course website. So since this is a virtual class, I think it'd be nice to kind of give a tour of that. And then after that, we'll go over the syllabus. But At this point, are there any questions that I can answer before we tour the course website? Okay. All right, so here's the course website. So it's going to be on Canvas, right? And so maybe a lot of you guys have seen it already, but when you first come to the homepage of the website, you'll be greeted by this, okay? And so the first thing that you'll see is hopefully the title of the class. And then next you'll see some basic information about the class and about me, okay? And so here's me, I'm Professor Justin Tran, right? So if you click this, you can look at like my Tinder profile for teaching, right? So I'll let you read that on your own. And then here's my email address in case you forget it again too, okay? So I think if you click this, then it'll let you email me. It opens Outlook or something like that, okay? And then the class times is right now. So it's Tuesdays and Thursdays from 4 to 5:15 p.m. Okay. All right. And then from here, we have a description of the course, so you can definitely read that. And then we also have our course level learning objectives, right? And so the learning objectives, remember what I mentioned before, these are basically the objectives that we're going to be working towards for the entire class. Okay. And so by the end of the class, what I hope will happen is that you can read these objectives and you can say, I can do everything on this list. Okay. Next here we have the syllabus. And so if you want to download the syllabus, in about 15 minutes, we're probably going to start going over it. Okay. Next, we have all the Zoom links. So here we have the Zoom link for the lecture, which all of you guys are viewing right now. Okay. And then we have the Zoom links for the office hours too. So we have Monday, Tuesday, and Thursday. Okay. And so, what I like to do with my office hours is I like to put them at different times throughout the week because I know everyone's schedule is everyone has a different schedule. So I try to vary my office hours such that there's a time that there's at least one office hours time that you can meet. Okay. And so I have office hours on Monday mornings from 9 to 10 a.m. I had office hours today from 1 to 2 p.m. And then the next office hours is from 2 to 3 p.m. on Thursday. Okay. But even then, I know that these aren't perfect and, probably some of you guys either have work or other classes, you can't make these. So, if you want to meet with me in office hours, but you can't make any of these times, or, what tends to happen more often is that, the homework's due tomorrow and you want to talk about it, get some help the day before, I'm always, available for that. And so in those cases, just send me a message either on email or through Discord, and we can set up a time where we can meet and, I can help you out. Okay. And so, don't be afraid to reach out if these office hour times don't work for you. Okay. Okay. And so the next thing I want to talk about is our Discord server. Okay. And so, because we're doing virtual instruction, I thought a Discord server would be nice because normally what happens, in-person instruction is that, we have the physical classroom, we can all be in the same room, you can meet people, you can ask them for help. But, when we're virtual, none of that can happen. Okay. And so to kind of recreate that atmosphere or to kind of, create a place where you guys can kind of informally discuss and meet each other, I've created this Discord server for us to use. Okay. And so, if you have a Discord account, all you have to do is just click this link and then it will give you an invitation to join the course. Okay. Okay. And so here is our Discord server. Okay. So I see some people have joined, so I'll add you guys in a second. Okay. But I have 4 text channels here. Okay. So I have one channel for announcements. And so if there's anything quick that I want to tell the class, then I'll come here. And people are joining in real time, which is great. But you don't have to join the Discord server to get the announcements because anything important I'm going to put into the Canvas site too. So it'll email you. But if there's something quick that I just want to say to people, I'll use this. Okay. The next channel here is introductions. So if you're joining the Discord server, I would ask that you kind of just leave kind of a brief blurb about yourself. So we have Brennan and Arjun had already left their messages, so this is great. And so if you can kind of just state your name and just a little bit about yourself, I think that would be great, just so everyone can kind of get to know you. Okay. I have a channel for questions. So, this is probably the channel that'll be probably most active. And so if you have any questions about, the homeworks or you have questions about ANSYS, you can use this channel to ask questions and you guys can, of course, answer each other's questions. Okay. And so, I like this channel a lot because this kind of, especially, with ANSYS where, a lot of times in the classroom, I see people working together and you guys are helping each other through issues. This is what I want this channel to be used for here. Okay. And then finally, just for fun, I have a channel for memes too. So any kind of jokes or anything you want to make fun of me, make fun of my, not shaven face, you can do it here too. Okay. So I will say that, because I have 4 classes, you can see here, I've turned off notifications for these servers. So, I want these Discord servers to be mostly for you guys to interact. Okay. But, if there is something that, that no one seems to answer, or you want to ask me something, you can just tag me. Okay. So to tag me, you just use the @ and then my name's really easy. You just do professor. And then, just say something like, yo, help me, dog. Okay. And then that will, create a notification for me, and then you will summon me, and I will come in and I will answer your question, and then I will leave. Okay. So if there's something, that no one else can answer and you want to summon me, just tag me, and then I'll come in like that. Okay. Okay. So that's our Discord server. Right. And so next thing I want to talk about is our course outline. Okay. And so you can see at the bottom of the homepage here, I've broken down our class into each of the 16 weeks. Okay. And so as we go about the semester, these links will become active and you can actually click them. So actually, let's click this first link right here. And you'll see kind of the layout of what you can kind of expect from these weekly, I call them weekly pages. Okay. And so in each of these weekly pages, I'll write basically a short paragraph here to kind of describe, what we're going to learn this week. Okay. I'm also going to list out the learning objectives for the week. Okay. And then here's where I'll also post the recorded lectures too. So every lecture this semester is going to be recorded. And then once they're recorded, I put them up on YouTube, and I put the YouTube links here so you can view them kind of afterwards. Okay. So that's, one of the nice things about virtual instruction is that's kind of done automatically for you. Okay. And so in addition to the recorded lectures, I have one additional video here about the virtual computing labs. And so this video will basically show you how to access the virtual computing labs for ANSYS. Okay. Because normally when we have this class, we have access to the computer lab where you can run ANSYS, right? And so you don't have to run it on your own computer. But since we don't have access to that, you can basically remote log into some of the computers we have on campus using this this portal called the Virtual Computing Labs, and this link will basically show you how to do that. Okay. And so this is really important where like maybe if your laptop, you don't think it can run ANSYS, or if you have a Mac, that tends to be the most common, right? You don't have to get a Windows machine. You don't have to get a new laptop. You just have to basically use this virtual computing labs, and then you'll have access to the full ANSYS suite that everyone can access. Okay. Okay. So another thing on these weekly pages is that you'll see any assignments that I have. Okay. So any kind of homeworks or ANSYS activities will be here. And so we have our first homework, which is just your email introductions. And so we'll talk about that later in the class today. Okay. And then just any files that that I'm going to give to you guys too. So here's where I typically post all the lecture notes, all the homework solutions, any kind of study guides or any kind of instructions here I post here too. Okay. And so you can see here I have the slides from today. So here's the introductory lecture slides. I have the lecture notes where we're going to go over on Thursday, which is our review of kind of the math. Okay. And I also have instructions here where if you do want to download ANSYS onto your computer, here's instructions for you to do so. So just download this PDF and just follow those instructions, and you can download ANSYS onto your computer and use that. Okay. Okay. So any questions on the course website so far? Okay. Okay, so that's everything on the home page and also on the weekly viewer. And so let's look at some of the other tabs here on the left. Okay, and so the first tab here was we have announcements. Okay, no question. All right, so question. So are we using MATLAB in this class? So we'll be using MATLAB very lightly. And so what I mean by that is, when we do set up some linear equations, we're going to use MATLAB to solve them, so you don't have to do it by hand. But there's not going to be any programming. So we'll review it a little bit on Thursday, but there's not going to be any programming, so you don't have to worry about that. But you will need MATLAB to solve for some of the solve the problems. Yeah. Another question is the textbook required? No, it's not. But we'll go over that once we go over the syllabus. Yeah. Okay. So the announcements tab. So you'll probably never visit this tab at all. So basically, this is just an archive of all the announcements that I'm going to send to the class. But anytime I make an announcement, it'll automatically email you the same thing. So, if you're just checking your email regularly, then, there's no need for this. But if for some reason, if you want to view the archived list of announcements, you can come here and do that. Okay. Okay, so the next tab we have here is assignments. So this shows a summary of all the assignments. And so you can see, when they're due and when they're available from. Okay, so anytime I post a new homework assignment or something, or a new ANSYS activity, it'll show up here. Okay. The next tab here is your grades. And so, you can come here and view your grades. So this is just kind of a summary of, all the graded things and what you got on them. Okay. And on the right here, you can see how the grades are broken down. Okay. Next here, we have people. So if you want to see the list of everyone that's in the class, you can go ahead and do that here. Okay. And then the last tab here is files. Okay. And so, if you want to just, download a certain kind of file from the class and you don't want to look for it in kind of the weekly views, then you can come here and download the files. Okay. And so I have different folders here for the lecture notes, for the project, any kind of solutions or homework assignments, I put all the files here. Okay. And so, links to all these files will be within the weekly pages, which I showed earlier. But if you just want to search for a certain file, you can, and you just want to download that, you can come here and search for that too. Okay. So you can kind of almost think of this as kind of like the Dropbox for our class. Okay. Okay. And so that's everything on the course website. So are there any questions before we start talking about the syllabus? Okay. All right, so let's go over the syllabus. Okay. Okay, so first thing is office hours. So, we talked about this before, but, these are my times for the office hours, and they're going to take place over Zoom. Okay. And so office hours, typically what they're used for is if you're confused about any of the course content, or if you have questions on the homework, you have questions on the exam, or, you need clarification on something, office hours are a great time to discuss that. Okay. Or if you just want to come by and just say hi, that's always nice too. So the past couple of days, I know it's the first week, but no one came to office hours. It was, kind of lonely. So if you want to come by and just say hi, I always appreciate that too. Okay. Okay. So here are course level learning objectives. So we went over this on the course website, but here they are again. Okay. And again, what I hope by the end of the class is that you can look at this list and say that, you can do everything on here. Okay. Okay. Homeworks and exams, right? So I have 8 homework assignments that are planned. So 6 of those will be ANSYS activities, and 2 of those will just kind of be regular homework assignments. Okay. There's going to be 2 midterm exams and 1 final project. Okay. And so, just like I usually do, out of this 8 homeworks, whatever your lowest score is, I'm going to drop that, just because I know it's a long semester and lots of things can happen. So I want to give you guys the flexibility, so you don't have to be kind of perfect on your homeworks and turn them all in. Okay. But please do them all, especially the ANSYS activities, because that's your chance to really get practice with the software. Okay. And so since this is an elective class, and I think for this class especially, I usually do this where I just grade the homeworks on completion. So I'm not going to be grading for correctness or looking for correctness on your homeworks. Okay. And so for the reason for that is, because this is an elective and, we're not forcing you to take this class, I generally feel like, everyone that's in this class is here because they want to be, right? And so there's, and so, everyone's going to, put in a lot of effort into the homeworks, and that's what my hope is. Okay. But because of that, I'm not going to be grading or giving you feedback on your homework. So, whenever I post solutions, it's going to be your responsibility to go look at those solutions to help you prepare for the exams. Okay. Project. So let's talk about that in a bit. Okay. Okay. Midterms. They're not going to be cumulative, and so the midterms are basically just going to be kind of one chunk of the semester. But the final project, you're going to rely on knowledge from the whole course. Okay. I guess we can talk about the project now. So the project, it's designed to be an individual project, but I have allowed groups to work. I have allowed groups to work on it in the past. Okay. Because a lot of times, I know a lot of you guys are coming from the same legacy project. So I know, there's probably a group of you from Formula, there's probably a group of you from Baja, there's probably a group of you from Aero. So typically I let you guys kind of group up together because you're all kind of working on the same project anyway. But if you are going to do your final project as a group, my expectations are going to be a little bit higher. So I'm going to expect a little bit more work, and I expect the report to be of higher quality than the individual ones. So, so you can do groups, but it's designed for an individual project. So, kind of keep that in mind. Okay. All right, and so here's all the dates that are planned for the midterm exams and the due date for the final project. So our midterms, are going to take place on these days. And so they're going to be in-class midterms. And so what I did last semester was I did 24-hour exams, but I ended up having a lot of issues with academic dishonesty. So to kind of cut down on that, I've kind of been forced to just do in-class exams again. And so, because I know it's a virtual environment, and I know it takes some time to scan and upload the papers. I'll make my exams shorter than they usually are. So they're going to be shorter exams, but you're only going to have the class period to do them. Okay. And then the final report will be due Sunday, May 23rd. So that's going to be the Sunday after finals week. So, I basically, that's basically the very last day that you guys can turn it in, and, to give me enough time to grade them before grades are due. But, I want to make sure that I give you enough time to do that. Especially because I know finals week is always kind of crazy for you guys, especially for the graduating seniors. Okay, so course grades. So here's how the grades are going to be broken down. Okay, so homework's going to be 10%. Each of the midterms are going to be 25%, and the final project's going to be 40%. Okay. This last point is not true. I thought I took this out. And so all the homeworks will count the same. So there's no double counting. Okay. And then based on your score at the end of the class, I'm going to assign letter grades based on this criteria. So this is pretty standard. Okay. And so usually I don't have this for finite elements because, the grades tend to be pretty high. Because, the final projects, I always love, you guys always do such a good job with that. But if the class average at the end of the class is below a 75%, what I'll do is I'll add a flat amount of points to everyone's grades such that the class average is 75. But usually for finite elements, I usually don't have that issue. So basically, for you guys, I would assume that, your grades are going to be what they are, as we go throughout the class. Okay, textbook. So textbooks are not required. But, I do have 2 textbooks that I use as references for this class. Okay. And so both of them are pretty good. And so if you do want to pick them up, definitely, find a cheap version of this. Or like I usually tell people, if you can find a free version of this through less than legal means, then by all means do so. Okay. Because, I still believe that the textbook publishers are basically owned by the mafia, and they only exist just to rip students off. Right. There's no reason textbooks should cost over $100, but that's just me. So if you can find like a cheaper or a free version of these textbooks, definitely by all means go for it, because finite elements has not changed within the last 20 years. So if you get a version that's like from 1990s, 1980s, perfectly fine. Finite elements is still kind of the same as it was before. Right. Okay. All right, so course website, we've talked about this. So, this is where all the lecture notes and everything will be posted. We talked about the Discord server, okay? All right, course policies. So late homeworks. So I do accept late homeworks, but because, they're due after the date, I do have to take some points off. So each day that your homework is late, I dock 10% from the points, okay? And so I do this, because, if you miss a date, I don't want you to feel like it's the end of the world. So, I want you to still be able to turn it in. But, because you didn't make the original date, I do have to take some points off. So that's kind of my policy for that. Okay. So regrades. So if you want me to regrade something, definitely, I'm open to that. I'm human, just like, everyone else. So I make mistakes. If you've had me as a professor before, I make mistakes all the time, probably too much. And so if you think, you deserve more points on like an exam or on your project, definitely, let me know. I'm always happy to look at things again. Okay. But, in order to be qualified for a regrade, you have to do this within a week after I return it to you. Okay. And so don't come to me, in week 16 of the semester, saying you want to regrade on midterm 1, because it's too late. Okay. And the reason I do this is because, when I do, grade things for correctness, I'm giving you guys a lot of feedback on your work. Okay. And I want you to view that feedback kind of within a timely manner, because if you're kind of waiting, a month or 2 months to read feedback from, way back when, then it's not really helpful for you. And it's, it's not really a learning experience. Right. And so, I do, whenever I grade something for you guys, I want you to be looking at it because I want that to be, an experience where you can kind of learn from this and, and you can apply it towards the final project or, other things, as well. Okay. And so kind of encourage you guys to kind of look at the feedback that I give you. I have this kind of 1 week time limit for if you want any regrades. Okay. Okay, and then email. So if you're going to email for the class, please include EGME 410 in the subject line. And so this is really important because I'm teaching 4 different classes this semester. And so if you include EGME 410, it really helps me to kind of sort out my email. Okay. And if you do this, I'm usually pretty fast with my email. So I'll either respond same day or I'll respond, within 48 hours at the absolute latest. Okay. Okay, graduate credit. So I know there's some grad students in this class. And so EGME 410 is eligible for graduate credit. But in order to get graduate credit, you must complete an additional assignment. Okay. And so, if you're a grad student, definitely, let me know. Send me an email. I know some of you have done that already. So thank you for that. And then we'll talk about the additional assignment later in the semester. Okay. So I haven't decided exactly what it's going to be, but, you'll know, within, maybe a month or 2. Okay. Well before the semester ends. Okay. Okay, so academic dishonesty. So, I always dislike talking about this, but, this is, especially more relevant now because, just as a university, we've kind of seen, a big rise in academic dishonesty. So, just because it's virtual, doesn't change the rules of the course. So, just like anything, academic dishonesty will not be tolerated. Okay. And so if you do commit academic dishonesty, at the very least, you're going to get a 0 on that assignment. And if it's on something serious like an exam, there's, I have to give you an F for the course. That's kind of just the policy that we have. Okay. And the reason for this is, end of the day, cheating takes away from your learning, right? So you're in this class, you're paying a lot of money for tuition to learn a skill, right? That you're going to use in your profession, right? And if you cheat, that kind of shortcuts that it kind of short circuits that learning where you're not getting as much. Okay. But, if you do feel like you're struggling and you do feel like, you need to cheat in order to succeed in the class, just please, please, please. The only thing I ask is that you give me a chance, to help you out first. Okay. Because, I really believe that I'm here and the school pays me to help you guys succeed. Right. I'm not here to, to gatekeep anyone or to, or to be mean to people, right? I really want everyone in this class to succeed. And, I know things can happen throughout the semester where, things get busy or, or just the material is hard, or maybe I sucked at teaching it that, that day. I know there are going to be times in the semester where, it's not always going to be easy, but during those times, I want you guys to reach out to me, send me an email, send me a message on Discord and say, hey, professor, I really need help understanding this, or, I'm really stressed that I'm not going to do well in this exam, or, I don't think I'm going to get this homework in time, because when you do that, that gives me a chance to kind of work something out with you guys, right? So I'm always happy to make adjustments. I'm always happy to, provide extra help or, to give you extra office hours to really help you through those issues, but if you don't reach out, and you cheat on an exam or something, at that point, I can't do anything because, our college and our department, we have very strict policies on cheating. So, before any of that happens, please just reach out to me, and I promise you, I'll do everything I can to help you succeed, right? I'm not going to judge you. I'm not going to lecture you. I'm not going to, do any of that. I'm just going to, just do my best to kind of help you out because I really believe that's what I'm here to do. That's what I'm paid to do. Okay. Okay. And so with that, we've reached the end of our first day here. And so the last thing I want to talk about is your first homework assignment. Okay. And so if your first homework assignment is email introductions. Okay. And so the only thing you have to do is just send me an email to introduce yourself. Okay. And as soon as you do that, you get full credit for completing it. Okay. And so make sure to at least include your name, your year, and your major so I can give you credit for the assignment. Okay. And if you're having trouble, finding out or figuring out what to talk about, here's some questions that you can consider. So, what kind of career do you want to have after graduating? What do you want to learn most? Do you have any worries or concerns about this class? And, what are your interests and hobbies, right? And so you don't have to answer these questions. You can just simply send me an email and say, hi, my name is this, please give me credit. And, you'll get full credit for it. But I really do appreciate, when you guys, take a lot of time and write a lot of detail by yourself, because, getting to know you guys and, is a big joy of my job. So, the more that you write, the more, it's enjoyable for me and the more I can comment on that, right? And most importantly, what tends to happen with these is that, once when you guys tell me about, what you want to get out of this course or what kind of career you want to have, that helps me kind of tailor this class and kind of steer it in directions to kind of be most useful for as many people as possible. Okay. Especially with a class like this with finite elements, there's a lot of different directions that we can take this class, right? And so, if you guys tell me, what you're most interested in learning, I can steer it in those directions such that, it's as useful to people as possible. Okay. And so if you can send me an email by this Friday by 11:59, then that would be great. Okay. And make sure to include EGME 410 in the subject line. Right. Okay. So with that, I'm going to end class a little bit early today. So are there any final questions before we sign off?
I have a couple questions.
Yeah, sure.
Okay, so just, I guess, how are you going to be handling, like, taking attendance for this class? Because, like, you can't, because this isn't a physical thing, so, like, how do you handle that?
Right. Yeah, that's a great question. So, so I'm not going to be taking attendance. So, so definitely, you're free to, come to lectures or not, because I know, my schedules get busy and stuff like that. But I am recording all the lectures, so you can view the lectures on YouTube if you don't get a chance to come to the course. But I'm not going to be taking attendance for the class. Right?
Okay.
Yep.
And secondly, this is probably just, like, a problem on my end, but I joined the Discord server and it's not letting me post any messages on it.
Yeah. So I have to give you permissions to do so. So I know a lot of people kind of joined in a big fury, during the lecture today. So I need to give people permission. So that's mostly just to prevent trolls from coming in and doing stuff on the server. But I will do that right after the lecture. Yeah.
Okay. Thank you.
Yep. Right. And then there's a question about the Canvas site. Yeah. So it usually takes about 24 to 48 hours if you just enrolled in the course. So if you just enrolled today and the Canvas site isn't showing up to you by tomorrow, just send me an email and then I can add you directly. Yeah. Okay. Yeah. Yeah. So I'll keep the call open for for another few minutes. I do have another lecture at 5:30 I need to run to, but I'll stay in and answer any questions that you guys have, either about the class or I guess, the last couple lectures that people have asked me about my personal life too. So we can do that too. But, if you have no more questions, we'll, I'll end here and I'll see you guys on Thursday. Right? Actually, give me like 2 minutes because I need to go pee really bad. So let me go pee and then I'll come back and answer questions. Right? Thank you guys.
Thank you.
All right, I'm back.
Professor, I was wondering if we have you for 2 classes, can we just send one email and then put both classes in the subject line?
Yeah. Please do that. Yeah, just send one email and just put both classes. Yeah.
Okay.
Professor,
Yep. What's up?
the following class, I'm in that class as well, the cardiovascular one.
Yep.
Is that one going to be somewhat related to what we're doing with this class?
It's going to be pretty different, actually. So the cardiovascular one, we're going to be talking a lot more about, how do we apply these tools to biomedical stuff, basically. So a lot of the class is actually going to be like biomedical, it's almost like a biology class. And so we're going to be using similar tools, but I would say, this class we're going to be using ANSYS, but in the cardiovascular one, we're going to be using different tools for that. Yeah.
Okay, thank you.
Professor?
Mhm.
I sent something in the chat. Please don't fail me.
Hang on. Okay. Let me see.
You said I could make memes, so.
Yeah, please make memes. I love memes. Post that in the Discord channel. Actually, let me go add everyone that added the class right now.
Gave me an opportunity and I took full advantage of it.
Yeah, go for it. I love it. Yeah, no problem. Yeah, for those of you guys who are downloading the textbook, I know it's a big file, so I'll stay on for a bit. Mhm.
Okay, so I think I was a bit distracted at point, but like the email you guys are talking about, that's just the homework assignment, right? Like I don't
Yes.
need any other one.
Yeah. So if you've already sent it, then you just have to just send it once. But yeah, just send an email, just introducing yourself.
Should I also put all that into the Discord introduction, or
No, it's okay. I mean, for the Discord introduction, that's more to introduce yourself to the rest of the class. So just kind of a really short thing for that.
okay?
Yeah.
So thank you.
Mm-hmm.
I'm gonna go leave now.
Yep. See you Thursday.
See you, Professor.
See you guys.